Okay, this is lesson 1C from the Practice of Statistics, 8th edition. So these are our goals or targets today. We're going to learn about dot plots, the shape of a graph, which matters on a dot plot, describe the distribution of this quantitative variable. So right away, all of this data, we're talking about quantitative. I think the last couple of graphs we've been doing have been categorical. So we're going to learn about stem and leaf plots, which you might have seen before, but they're a little different, and then histograms. So wow, a lot of stuff in one lesson. So you can use a pie chart or a bar chart for categorical data. These are the three we're going to learn about today: dot plots, stem, leaf plots, and histograms. But actually, on today's lesson, I think we're just doing dot plots. I think we're just doing dot plots. So actually, I think the second half of this lesson will be the stem and leaf plots and the histograms. So it's like, man, that's a lot to do in one lesson. That makes sense. Okay, what's a dot plot? So it's a graph for quantitative data of the data, where each value is a dot in its location on the number line, so to speak. Yeah, it's fairly easy to do. And the calculator is going to do this for you as well, which really nicely. So James Bond is a fictional British spy created by the novelist Ian Fleming. The James Bond character made his way into the movie theaters in 1962 with Dr. No. I think I've seen that one. Here are the lengths and minutes of the 27 Bond movies released to date. I don't know if those are in order or not, but those are all the different things, and that's okay. We'll put it in order when you make the dot plot. Make a dot plot of these data. So you want to start with the bottom. There's just one axis for a dot plot. There's no side axis really. It's just one axis. So these are, I guess you would label it like the length of James Bond movies, right? So you'll have to scale it out first. So you have to decide, like the lowest number I see written there is 100, just a little over 100. So I might go from 100 to, I don't know, 170. I see 163 there. I think that might be enough. So they went from one, I would definitely go more than 160. That's not big enough. 163, you have to go at least to 165 there. I don't know what they're doing. But 105 is fine because that's smaller than 110, which I think is the smallest number up there. So then you're just going to place the dots appropriately. And if there was 3 130s there, if you notice that, 3 130s, so you can see they stacked them up. There's 3 131s, they stacked them. So if you get the same value twice, you just stack it. And that's basically a dot plot, right? You can do this in the calculator as well. So for fun, let's try it. So we're going to go to down to listen spreadsheet. So I hit the home key, and then I went to listen spreadsheet. It looks like an Excel spreadsheet there. And we're going to list out, we're going to call the name. So go up to the very top, and we're going to call it Bond or something for James Bond. And so I'm going to type all the numbers in. And this is helpful. It'll help us crunch some numbers. We can do some stuff with the calculator on some of these lessons. So this is not just helpful for this lesson, but other lessons. You need to know how to type data in and let the calculator crunch some numbers if you need it to. Hopefully I'm typing this all right. Oh, wow. 143, and then 148, and then 163, and 131, and 134. Okay, there's 27 pieces of data. Is that right? 5 times. Yeah, that looks about right. So maybe I actually typed these in right. They look okay. So to graph them, hit Control Doc to add a page. Go to Data and Statistics. We do this a lot in stats, and then click this bottom axis or hit Tab and choose Bond. It scales it out for you, stacks them. You can see in some ways it's not as nice as the one by hand because it has funny stacking them. It's like, it's kind of on top. It's not quite on top, but that's the idea of it. And it'll do a pretty good job for you. And again, this allows us to do other things with the data that you couldn't do that we might need later. So I just want you to know how to do a basic dot plot in there if you need to. Again, you may not be necessary on the AP exam, but we'll see. Remember, each dot represents one data point. That makes sense. 117 is that dot right there. Any movies that last more than 2 hours, considered long by many viewers. Can we use the graph in Part A to justify the claim that more than 75% of these James Bond movies are long by this criterion? So let's see, longer than 2 hours, so that'd be longer than 120, right? 120, I guess. More than 2, so more than 120. So anything number more than 120. So it's easy to see on the graph, right? You kind of see where 120 is, and you can count them out if you needed to. So there's 7 that are 120 or below. So there must be 20 that are above. So 20 out of 27, or 74.1%, are longer than 2 hours. Because 74.1 is less than 75%, the dot plot cannot be used to justify the claim that more than 75% are longer than the criterion. So that was the question. Is there more than 75%? Well, it's a little bit less. Not a lot, but a little bit. I guess you could make it vertically. We don't usually do that. It'll help you justify a claim, that's for sure. What do you see? When you describe the shape of a dot plot, so this is important now. So now, remember, we didn't have shape for bar charts, but for dot plots, we are going to have shape. Look for clear peaks, not for minor ups and downs. You look at the general trend, like for clusters or obvious gaps. So first of all, does it look pretty symmetric here? I'd say it looks symmetric, right? So you might describe that as symmetric with a peak in the middle there. So here's the definition of roughly symmetric. And we like to use terms like roughly or approximately symmetric because it's like very rarely is it perfectly symmetric. It's pretty symmetric. It's roughly symmetric. Or is it skewed to the left or skewed to the right? We're going to learn about those in a second. But this graph looks to be roughly symmetric. The right side and left side look about the same. It's like a mirror image. Later on, we'll learn what a normal curve is. That might or might not be normal, but it's definitely symmetric or roughly symmetric. This is what a graph looks like if it's skewed to the left. Can you see that the shape of the graph, the skew, you can almost ski to the left, like the skew is to the left towards the outliers, maybe on the left there. Skew to the right, it skews in the other direction. So it kind of slopes or kind of skews towards those right values. Is towards the long tail, not in the direction where the most observations are clustered. So like when it says skewed to the right, you're pointing at that tail to the right. The tail goes to the right there. So you're kind of pushing towards those potential outliers there on the tail. Again, it might help you think of skiing to the left or skiing to the right, skewing to the left, skiing to the right, skewing to the right, I should say. Okay, here are two different sets of dot plots. Graph shows the total number of college, let's see, on the left, average number of students per faculty member. Total number of students in colleges and universities. So two totally different graphs there. Describe the shape of each. So the first one, the shape looks, I'm okay with roughly symmetric there. It's not perfect, but roughly symmetric. Part B, though, clearly that guy is skewed to the right. You see that outlier on the right? It's skewed towards that outlier. Yeah, it's skewed to the right. So this one looks roughly symmetric. Don't worry about those, just little, not perfectly symmetric, but it's roughly. With a single peak at 14 students per faculty member. This one definitely skewed to the right, with a single peak at around 100,000 students. Oh yeah, those are listed at hundreds of thousands. So that would be about one, which is 100,000. Okay. They even described, let's see, a gap between the 1,100,000 and the, or in other words, on the graph, between the 11 and the 16, there's a gap. Between the 16 and the 25, there's a gap. So what is approximately uniform? That's another shape. So we just talked about approximately symmetric, skewed left, and skewed right. Those are kind of the three main ones. You'll see this. Uniform means it's approximately straight across the top here. Can you see that data looks kind of straight along the top, I think? So that's what that's going to be. It doesn't mean it's perfectly straight, but it seems equally likely to get between a 1 and a 6. If you roll a dice, are you equally likely to get as many 6s as 1s, as 2s, as 3s? I think that's fair. So this data does look, and it should look, approximately uniform. Uniform and bimodal. So unimodal means there's one peak. Bimodal means there's 2 peaks. So there's text messages. Yeah, that's unimodal, or roughly symmetric there. This one might be called roughly symmetric. I might be okay with that, but it's definitely bimodal, right? So that's the big thing you want to say there for sure. You want to talk about the shape, the center, and the variability. And if it has anything unusual, like outliers or something. Always answer in context. Talk about what it represents. Is it about duration of something, or is it the text messages, etc.? Okay. Tropical cyclones are severe rotating storms that originate in tropical oceans. One measure of the severity of a tropical cyclone is the maximum sustained wind speed, which is used to classify storms as tropical depressions. Those are the least severe. Tropical storms, hurricanes, or major hurricanes, which are the most severe. Here's a dot plot of the maximum and minimum sustained wind speeds in knots in Atlantic Basin over an 11-year period. Okay. I like the dot plot. Describe the distribution. So again, what do we want to hit? Shape. Clearly, that shape is not approximately symmetric. It looks like it skews to the right. Potential outliers at 160, but we don't really know that. But that's okay to say for something unusual. But there's a potential outlier at 160 knots. Center. So it definitely skewed to the right. No apparent outliers. So the center, the middle value is about 55 knots. So the median sustained speed is 55. So how did they find that? You might go, well, how did they find that? Well, there's 193 different dots on this graph. They told us that. The peak is 45. That'd be the mode, I guess, if you wanted to know the mode. So the median is a measure of center there. So if there's 193 dots, I'm going to get my calculator out. So 193 divided by 2 is a decimal, 96.5. So the 97th term, if you think about it, there's 96 terms before the 97th term, there's 96 terms after the 97th term. So I'm looking for the 97th term. So if you would take now it's hard to count these, but if you actually counted 1 in that first column, then you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that one. 10 in that one, so that's 21. Keep counting until you get to the 97th term. And the 97th term is somewhere in this bar. So you would say the median looks to be about 55. It's hard to even tell what that value is, but it's in the 50s there for sure. So the graph wasn't labeled super nicely there. So about 55, that's the median. And then the variability is how spread out it is. So the maximum is about 160. The minimum is about 25-ish. So yeah, it varies from 25 to 160. And that's enough to say right now, we're going to learn more about these mean, medians, and modes, and ranges, and standard deviations, and IQR, measures of spread. So we're not quite there. So just talking about the variability, it goes from about 25 to about 160 there for the cyclones. Yeah, what questions you have? So that's a very quick lesson, actually. So probably could have done more there, but that's the idea of that one.